All right, let's concentrate on Titan for a moment. As I mentioned earlier, the Voyager 1 spacecraft, when it got to Saturn, deflected and studied. It was still just a pass by, but Titan was so interesting that basically we sacrificed. Um, not sacrificed because it was still working, but the original plan was for the Voyager 1 and 2 spacecraft to visit Uranus and Neptune as well as Jupiter and Saturn. Um, of course, the Voyager 2 went on and continued to and visited Neptune and Uranus and Neptune in the 1980s. But when Voyager 1 had gotten to Saturn, to get better pictures of the moon Titan, which we knew to have an atmosphere. That was the big thing. That was the it had this atmosphere. We wanted to study it more. It was larger than the planet Mercury. Just like the Galilean moons around Jupiter. Well, three of the Galilean moons around Jupiter are larger than Mercury, and the fact that it had an atmosphere really piqued our interest, and so we examined that. Later on in I think it was the early 2000s, um, that the Cassini spacecraft, when it got to Saturn, it actually carried a little probe that it released. It was called the Huygens probe, and the Huygens probe was intended to land on Titan because the clouds. I mean, one of the things that we found out was, from the Voyager spacecraft, was that the clouds were so thick on in Titan's atmosphere that we couldn't see the surface, and of course, we wanted to be able to see the surface. Um, so when the Cassini spacecraft got to Saturn, I think it was in the early 2000s. I can't remember exactly when it was, but when it got there, it had this thing called the Huygens probe which actually parachuted down into Saturn. It gave us some really nice pictures of Saturn, and of course the Cassini spacecraft had radar, and could pierce through the clouds. We knew that, but that was part of the reason Cassini was designed the way it was, is so that we could study Titan in more detail. And they found that um, there were some impact craters, but not as many. Um, and it seemed as though, first of all, this is actually some a picture from the Huygens probe, from the ground, from the surface, and so there's some rocks. Um, you can see when you look into the sky there, you can see the atmosphere is really thick. Um, but one of the things that the Cassini spacecraft was able to do, was with the radar images, is they found that there was liquid on the surface of Titan, and this was the first time ever that liquid had been discovered, to exist outside of the Earth. Uh, but it wasn't. Titan is really cold because it's really far from the sun. Um, and because Saturn's really far from the sun, of course. Uh, but the lakes were not water, in this, like they are on Earth. They were actually made of ethane and methane. These are carbon compounds, and yeah, that was actually a huge surprise. Is that these liquid lakes actually existed on the surface of Titan with its thick atmosphere. This is a different moon. This is the yeah. Let's see. Do I have anything else to say about Titan? One of the things that we realized very quickly when we determined that the atmosphere of that Titan even had an atmosphere is that its atmosphere would seem to be very similar to what we think was the atmosphere of the Earth in the very early solar system. So it was mostly nitrogen, and there was carbon dioxide and methane and stuff like that. But no oxygen. Certainly, remember on the Earth, the oxygen comes from photosynthesis. We don't think there's any photosynthesis taking place on Titan. But it was an interesting place to study, and still is an interesting place to study. All right, so let's move on to some of the other. So as I mentioned, Titan, of course, is the large moon of Saturn. It's the largest moon of Saturn, and then there are these other. Here, let's look at the pictures of them again. These are more or less you'd consider them medium-sized moons. Enceladus and Mimas and Iapetus, Dione, Rhea, and Tethys. All right, so those are medium-sized moons. Let's get to, so Iapetus has it's in a synchronous orbit. It undergoes a resonance with Saturn, and at the same side of Iapetus faces Saturn, like as it orbits. All right, just like our moon does. Our moon does that too, right? It's in a 1-1 resonance. So every time Iapetus spins around its axis, it's gone around Saturn once. The side of the moon that faces forward as it orbits Saturn, and so it faces Saturn, has this extremely dark material. And that dark material has been identified as this carbon-rich material that it's not living, but it's certainly organic in nature. Organic because it has carbon molecules, and they're called tholins. All right, so and we did find this dark material on Pluto of all places, many years later. All right, then we get to besides Titan, which is certainly interesting in the fact that it has lakes and it has an atmosphere. Is Enceladus. So Enceladus is a tiny moon, as you saw. As far as these medium-sized moons, it's the small. Well, I guess Mimas is a little bit smaller, but it's a really small moon. But from the density of it and the surface of it seem to be rather smooth. I mean, there's some impact craters, but not a lot of them, and like I said, there seems to be these cracks as well, which indicated that the moon might be made mostly of water, of ice, water, ice, and perhaps even liquid water. And that was actually verified by the Cassini spacecraft. Enceladus, on its south pole, there are actually water geysers. This is actually salt water coming out of the South Pole, these cracks in the South Pole, indicating that, of course, Enceladus has a liquid ocean. The interior of it is a liquid ocean, which, of course, begs the question, could there be life on Enceladus? Again, using the model of the smokers on Earth, these extremophiles that live deep under the ocean and get their energy from the heat that comes from the smokers. All right, so and remember, this was very surprising. The fact that there was active geology going on Enceladus, the fact that it's so far from the sun and it's a tiny little moon. Why would it be blasting out geysers of salt water? What's going on? Again, the reason has to do with, it's the same reason that Io going around Jupiter is volcanic. It's because Enceladus undergoes these the tidal forces. It's in a rather elliptical orbit. That is, it gets closer to Saturn and further from Saturn, and in a more extreme manner. And when it does so, it gets squeezed, and that squeezing is turned into heat, and that heats up the interior, and sometimes the water comes flying out in the form of a geyser, right? All right, and the other thing is, we with this, as the Cassini spacecraft was getting towards the end of its life, we actually passed the Cassini spacecraft through the geyser, and sampled this. That's how we know the salinity of the geyser. We know that it's salt water, and we actually we measured the salinity of it as well. And that goes to the other thing about when the Cassini mission was over, and I know I've mentioned this already, but it bears repeating. NASA decided that if there is life on Enceladus, and some future mission perhaps will prove that one way or the other. I mean, it probably will take multiple missions, to be honest with you. But if there is even microbial life, little microbes that exist, deep in the oceans of Enceladus, do we have the right to interact with that? Right? I mean, there's lots and lots of microbes on Earth already, and should our microbes that have had 4 billion years to evolve, should they interact with, if there are life forms on Enceladus, do we have the right to interact with those life forms? I mean, it's certainly an interesting ethical question. That certainly, it's one of those things that people have been thinking about, and so when the Cassini spacecraft was towards the end of its mission, they turned it towards. They actually passed it through the rings of Saturn. Hey, let's go back to the rings of Saturn and look at that real quick. It actually, we passed through the rings of Saturn. Here, let's get a better picture of it. And I think we actually went between the gaps, just to see what we could see. And at that point, the spacecraft was close to 20 years old, and if it encountered one of these, even a small little chunk of ice, it would have destroyed it. But it didn't. Actually, it went past this and gave us even more information. And ultimately, what we did is NASA decided, okay, let's just plunge this Cassini spacecraft into Saturn. And as there's actually video on YouTube. Again, I'll try to put the links of the spacecraft going into Saturn and sending its last message to the Earth. and then it